So how do we calculate our sampling frequency and sampling interval of the continuous signal? Well, given x of t, we want to calculate the discrete points along the signal. In order to do this, we first need to know the sampling frequency, the number of samples per second, and the sampling interval, the time interval between samples. To calculate the sampling frequency, you take the maximum frequency of your continuous signal and multiply it by 2, which is called the Nyquist rate. And your sampling interval is just the inverse of your Nyquist rate. But let's look at an example. Let's say we have a 60 Hz cosine wave, so our x of t is cosine of 2 pi 60t. Luckily, this signal only has one frequency, therefore it is the maximum frequency, and we call it omega sub c. So our Nyquist rate is just twice this maximum frequency, or 120 samples per second, and our sampling interval is the inverse of this Nyquist rate, or about 8.33 milliseconds. So to review, we wanted to calculate the Nyquist rate and the sampling interval of our continuous signal. So we calculated the Nyquist rate by multiplying the maximum frequency of our signal by 2, and then took the inverse of our Nyquist rate to find the sampling interval. Look at how to convert a continuous signal into a discrete signal using the given sampling rate. Given our continuous cosine signal and a Nyquist sampling rate of 120 Hz, to convert this to a discrete signal, simply divide the frequency of the sinusoid by the sampling rate. And here this gives a discrete sinusoid x of k equals the cosine of pi times k. This is in the time domain, and in the next video we will look at the effect of undersampling on the reconstructed signal using the frequency domain.
Thank you.